Right, so now that we've defined our correlation coefficient and we talked about what it means in context, we're going to talk about calculating it. So our correlation coefficient R is the sum of the products of the z-scores in the data set divided by the number of observation. So looking at our formula, notice that we have the sigma here for a sum like we did in our standard deviation formula from chapter 3. We see our z-scores of our x values, our z-scores of our y values. These are being multiplied together, and it's divided by the number of observations minus 1. There is an alternate formula listed here where instead of just putting our z's, we actually put our z-score formulas in there, but either way we want to kind of think about it, we've got the same thing there. All right, so calculating our correlation coefficient is something that we are able to do in StatCrunch. We're going to enter our values into 2 columns in the table. Unlike what we did in the previous section where we just graphed a scatter plot, we're going to go to Stat, we're going to select Regression, we're going to select Simple Linear, make sure we get our X and Y's in the right place and hit Compute, and it's going to give us not only our correlation coefficient but a lot of other things as we're going through. Again, I will be posting a separate video showing this example kind of worked through, or unexample, whether it's this one, probably this one, worked through using StatCrunch, so that way we can kind of compare what we're going to do here by hand to what we can do using the computer to assist us. All right, so this figure shows the association between the height and weight of a sample of 6 women. We're told to find the correlation coefficient. We are given for the height, our x bar, our mean, is 64. Our standard deviation for x is 2.608. For the weight, our y, our mean is 135, and our standard deviation is 26.73. Right, so what I've done here is I've created a table. In order to just kind of save some time, I filled in a bunch of these values down here. So what we would start with if we were building a table is we would start just by putting this information in, our x's and our y's, right? And the rest of this we would have to fill in line by line. Again, I'm just going to fill in 2 lines so that way we can kind of go through and talk about this, and then to save a little bit of time, I've worked through some of the other calculations. All right, so we need to take our height, and we need to find our z-score, and we need to take the weight of this first person and find our z-score. All right, so I'm going to use this area over here as some scratch paper. All right, so zx is going to be my z-score for my height. I am going to take, right, so we have an observed value of 61, we have a mean of 64. So remember, it's always observed value minus mean. So 61 minus 64. Divided by our standard deviation, which is 2.608. All right, and then z-scores we round to, in this case, usually we round them to 2 decimal places. I went ahead and left it as 3 decimal places for this calculation, so we get negative 1.150. So this is going to go right here. All right, and then our z-score for our weight. So again, we're going to start with our observed value, 104, minus our mean, which is 135, divided by our standard deviation, 26.73. We round this is going to give us negative 1.160. And then we're going to multiply these 2 values together to get our product. So negative 1.150 times negative 1.160 is going to give us a positive 1.334. All right, now we're going to do this again for our next data value. So now we have a height of 62. So our z-score, our observed value, 62, minus our mean, 64, divided by our standard deviation, 2.608, gives us negative 0.767. Right, then we're going to find zy. So we take our observed value, 110, minus the mean of 135 divided by our standard deviation of 26.73. And that is going to give us negative 0.935. Right, then we're going to multiply these two values together. Negative 0.767 times negative 0.935 is going to give us a positive 0.717. Right? And then what we just did for these two first rows that we've looked at, we would need to calculate a z-score for all of these different values. So that's where all of the rest of these are coming from. Again, just to save time, calculating 4 z-scores is enough. So I went ahead and did the calculations for all of those others, and then went ahead and found those products. All right, once we have all of these products done, so once we're done filling in our entire table, we're going to take these and we're going to add up these values. So we're just going to use a handy dandy calculator, and these add up to 4.403. All right, so again, that's what that sigma, that summation sign means. We're adding up those values. All right, now to finish it off, we're actually going to answer our question. We're going to find and interpret our correlation coefficient. All right, so R, using our formula, is sigma zx zy, which is what we just found in our table, divided by n minus 1. So we have 4.403 divided by 6 minus 1, because we had 6 people in our sample. We divide this out, this gives us 0.881. An R, or correlation coefficient, of 0.881 should tell us that we have a strong positive linear trend. Right. So looking at our calculations, obviously this is something kind of similar to what we see in when we're calculating our standard deviation. Right? We've got a lot of work that has to be done in order to get our answers. So we definitely are going to want to be comfortable using StatCrunch to go through and answer these questions. What we're going to get from StatCrunch for this exact same problem is actually at the top of the next page in our notes. It gives us a ton of information. So everything that we see here, the sample linear regression results, these parameter estimates, this analysis, and this picture are all different things that we are able to get from StatCrunch. In this particular case, we're looking for our correlation coefficient. Our correlation coefficient is going to be labeled as R. We see that here. We see that this also lists our dependent variable and our independent variable, so that way you can double check and make sure that this is your X, this is your Y. It's also going to give us an equation, which we're going to talk about in a little bit. It's going to give us an R squared value, which we'll also talk about in a little bit. But for right now, we just need to know where to find this correlation coefficient. And if we rounded this 0.880933363 to 3 decimal places, we would get the 0.881 that we just did, or that we just got in our calculation that we did in our table by hand to come up with our correlation coefficient.